Hey guys, let's go ahead and do some more work on magnets. So get out your fact files and your glue stick, and you also need these two sets of notes here. One that says why do magnets float and one that says lesson 3. All right, we're going to go ahead and glue in our pages. So the first one I want you to do actually is this one. Why do magnets float? So go ahead and get this one glued in. And then on the very next page on the back, get this one glued in. Okay. All right, and if you do not have it glued in, if you want to pause this, go ahead. And otherwise, we're going to move on. So the first thing we're going to be doing today is we're going to look at some magnets, and you're going to write a hypothesis. So let's start by looking at the magnets. So let me see if I can get this so that you can see it well. Okay. So on my screen, you will see these magnet rings. And you can see that they're floating. They don't touch each other. I can push them down and they don't stay down. They don't stay together. And I take them off and put it back on, still doesn't. So what you're going to do is make a hypothesis or a guess as to why you think that happens that way. Is Mrs. Medved magic? Or is there something else? So we're going to write a hypothesis about that. So getting back to our fact files. Okay, so here is the beginning of your hypothesis. I think the magnets float because, and you're going to finish that sentence. What is it that makes you think the magnets float? What makes them do that? So you're going to fill this in, okay, with your idea. Now, a hypothesis is similar to our predictions in our reading. You'd like for them to be right, but they're not always going to be right, and that's okay. But you make a hypothesis, you make a best guess as you think why, and then we're going to check it out, and then we'll come back and write down why they float. Okay? So if you need to pause there to finish writing your hypothesis, please do that, but please make sure that you finish this sentence and end with a punctuation mark. All right, so let's look at our notes. So the first thing we're going to write down is about the invisible area of magnetism all around an object. It's called a magnetic field. Magnetic field. So on that first line in your notes, you're going to write magnetic field. You might have to write a little small. I think I might not have made these spaces big enough. So magnetic magnetic field is an invisible area of magnetism all around an object. So if you think back to our lodestone, that naturally occurring rock, it has an area of magnetism around it that helps attract things. You can't see it, but there is an area of magnetism all around it. This magnet that we looked at the other day, it also has an area of magnetism around it. Okay, it doesn't go out as far as it wants to, but it certainly, if we get close enough, it attracts. So you can see that way out here there's not one, but as we get closer, it attracts it to the paper clip. So that's the magnetic field. It's all around, and it's that magnetism that brings objects to a magnet. So the next thing we want to talk about is magnets have north and south poles. Magnets have north and south poles, just like the Earth does. So go ahead and write down north and south poles. All right. Next, we're going to talk about when two magnetic poles are alike. They face each other, objects push away or repel. Repel is to push away from something. So on the line for number 3, go ahead and do repel. And then we're going to do one more for number 4. When two unlike magnetic poles face each other, objects attract. So go ahead and write those down, and I'm going to get something to demonstrate for you. My magnets are in a bag, and they're kind of a mess right now. Okay, so let me show you. So I've got a magnet here that has a north pole and a south pole. So if you see my magnet here, it's got an N on it. It's kind of hard to see. And there's an S at the bottom. So it's got a north pole and a south pole. Okay. So I have another one also that has a north pole and a south pole. So number 3 says when two magnetic poles that are alike face each other, objects push away or repel. So these are alike, north and north. So I'm going to put them to each other and try to make them, and they just kind of slide apart from each other. See that? I'm not doing anything to them. I'm just trying to push them so they stick together and they won't do it. And that's because they're alike. They repel each other. They push away. Okay, now when they're opposites, when the two unlike magnetic poles face each other, they attract. So I'm going to do a north, then I'm going to switch this one. So it is unlike, and look at that, I didn't have to do anything, it attracts. Let's see. One more time. See, they attract to each other. So again, when they're alike, nope, I can even do it with two souths. Nope. As much as I push these together, they do not want to stay together. It switches around so it can. All right, so now we have to think back as to why our magnets might be floating. Using what we just learned, why do you think these magnets that I had up here would be floating? So let's turn back to our hypothesis. And you have your hypothesis written down. And now we're going to talk about why they are floating. So why are these guys floating again? Well, it has to do with those poles. So if they're not sticking together, what could you say about them? Are there two likes facing each other, two norths or two souths? Or is it a north and a south facing each other that's causing them to repel? Well, we just learned that if they are the same, they repel each other. So what I can guess is that this side of this yellow and this bottom side of this green, those are both the same. They could be north, they could be south, it doesn't matter, but they're the same. Look what happens when I flip this over. I'm going to see if you can see me. Flip it over. So here's the way it was. I'm going to turn it over like this, put it back down. Now look what happened. It's stuck together. It's attracting. So, why do these magnets float? The magnets float. We're going to write this down. So let's look at our explanation. Okay, our magnets float because two unlike poles. Oops, not unlike, Mrs. Medved. Two like poles are facing each other. A better way to say it would be because two of the same poles, you could put that too. It actually would sound better, but two like poles are facing each other. That's why they float. That's why our magnets float, because they are likes facing likes. Okay, so now you know. It's not magic. It's just the magnetic fields and the way the poles are attracted to each other. Now, while you guys are finishing that, or you can pause it to finish if you need to, we're going to watch a short brain pop on magnets.
For my next trick, I will make this spoon move without touching it. Abracadabra! No, Moby, a magician never tells her secrets. Okay, I'll tell you. My wand actually has a magnet on it. What can magnets pull? Magnets can attract or pull objects that have iron in them. This nail is made with iron, so it sticks to the magnet. So does this nut, screw, and bolt. Your hammer is made out of steel, which is a metal made with iron. So it's magnetic. But not all metal objects have iron in them. Your coins and keys are definitely metal, but they are not magnetic. That can is made of aluminum, not iron, so it's not magnetic either. Magnets will not attract paper, wood, plastic, or rubber. Magnets can be different sizes and strengths. Some can pick up really large objects. Magnets may look different, but they all work the same way. What are magnetic poles? Magnets have two poles. No, not that kind of pole. The poles are where the pull of the magnet is strongest. Each magnet has a north pole and a south pole. On a round magnet, one side is the north pole and the other side is the south pole. Not exactly, Moby. Earth's core, or its center, contains iron. This helps our planet act like one gigantic magnet. Earth's poles are where the pull is the strongest. A compass points north because the needle is magnetic, and it's attracted to the Earth's north pole. The opposite poles always attract. So the north pole of your magnet and the south pole of mine stick together. But like poles do not attract. The north pole of your magnet and the north pole of my magnet repel or push away from each other. What is a magnetic field? A magnetic field represents the force around a magnet. When the nail is farther from the magnet, it's in a weaker part of the magnetic field, and the pull that the nail feels isn't as strong. But when I move the nail closer to the magnet, it's in a stronger part of the magnetic field, and the nail feels a stronger pull from the magnet. Right, magnets can move things even without touching them. Magnets can push or pull through gases like air. They can also attract and repel through liquids and solids. You're right, Moby. Magnets can do cool tricks. Hey, where'd you go? I don't think my magnet can do that.
Okay, boys and girls. So now you learned about magnetic poles and the magnetic field. So we will finish up tomorrow with our last lesson, and then we're going to have a test on Thursday. So please make sure you are studying your notes.